Sven.
Yeah, we're live. Welcome, everybody.
Welcome, everybody, to Labs Talk. Sven, how do you feel today?
I'm a bit stressed out. I started to sweat. I think I have water all over my body now. We just had some last-second audio and then also video issues. So that's why we're recording here and going live here in front of my MacBook.
I guess improvising is an art by itself, right?
I was running for 3.5 hours this morning, and I think I'm sweating more now.
So for everybody who doesn't know what we're talking about, is we typically have a bunch of audio gear here, and we wear headphones and have proper microphones and all that. And I don't know why, but we spent the last 30 minutes, and this is now falling back to notebook video and audio. So we excuse
but that doesn't look so bad, to be honest with you. Maybe we should just switch to that. I think I like it.
Cool. For those listening and for those paying attention, leave us a comment. How you like the quality.
All right, cool. But let's get back to our robotics series, right? So we have an awesome robotics series. We had one show already with the Evantro, right? With Alona, if I remember correctly. That was pretty exciting, and we're gonna have a couple more parts of that series dealing with robotics. So today we
let's remember Alona for a minute first. What do you remember from what does
what I especially liked about that part actually was that we had some videos, and we saw actually their robot running around in a home for elderly, basically.
Yeah, really, they do
and helping
elder care.
Exactly, it was about elderly care, and there was a test, basically a test setup that we were able to see on video, and it was really amazing to see, right? And I still remember, I was surprised that they want to be ready for the market in like 1-2 years, I believe.
And they do real world test runs already and trials already. But we do have another guest from the robotics space today. You were just about to announce our guest. I just interrupted you there.
Okay.
No?
Well, then let's actually bring Lisbeth on right away, actually, and welcome Lisbeth from KUKA. How are you doing?
Hello.
Hi. Nice to meet you.
Perfect. So Lisbeth, can you tell us a little bit what you do at KUKA? I guess everybody knows KUKA. I mean, very famous robotics manufacturer, of course. But what's your day job all about?
Yes, so thank you for the introduction. My job, I focus on knowledge management, and I'm leading a team of 13, and we share technical knowledge with our customers, also technicians, internal partners, and we collect information on new products, services, and create documents, training materials, and manage everything to bring it alive, so apps and websites.
So you're really at the source of all knowledge when it comes to KUKA, right? Did I get this right?
So to say, yeah, for the technical part.
Very cool.
I guess we have a few questions for you on what you're doing and why all of that is important. But before we get there, we were just bragging about that series on robotics that we're going to do, and to give you that intro, so to say. But to start with that, first question: did you actually see that episode that we did with Alona and those robots and care? Did you see that?
Yeah, I saw it, and it's pretty impressive how a young company can already be that far in their development. It's really, she did it great, and she had such a nice way to describe how what technical efforts they take to bring it onto the market, and the video is so impressive how they interact with the elderly people and how they bring these robots to life.
Very cool. If you see us smiling so weirdly, that's because Jörn is in the room and he takes pictures while we're actually talking. So it's he's kind of documenting our awesome setup that we have today.
We'll end up having a behind the scenes documentary. Lisbeth, when you introduced yourself, you were talking about how you're working in knowledge management. Maybe let's get back to that question, and you started there. Why is knowledge management so important, and the role that you play, not just for a robotics company, but I guess every high tech, any tech company? Why is that so important?
Yeah, that's a good question. Yeah, I would say it's very important to have well-structured data in order to have the knowledge inside of your company accessible for internal stakeholders like technicians, other employees who need to get onboarded and have their knowledge available. And not only that they are well trained, but also they have a possibility to look it up, so they know where to find knowledge and technical information. And when it comes to AI, well-structured knowledge data is also very important to train the AI. What we maybe can come to this later on also. So this is two facts that I see really important for the modern time right now.
I guess in particular AI is a keyword that really triggers more questions that we're going to have.
I mean, for me, it immediately triggers, when are we going to replace humans, basically, right? I know that's a bit over the top probably, right? But is that something that you kind of see happening at some point, actually, with all your knowledge about robotics and now AI on top? Is that something you find realistic?
Well, this is not. I think this is not a new debate, especially for KUKA, who is into robotics for 50 years now. And the same discussion that we have now with AI, we had it already with robotics. So the question is, are humans replaced by technology? And I think we need to have a different debate about it, because there is one question that should be in the focus about today's challenges. How can we overcome today's challenges? And when I think about them, it's about fewer specialists on increasingly complex projects. We have more and more people who retire and have their knowledge taken with them, and we have economical challenges, we have ecological challenges, and in my opinion, we need to react to them, and the best way is to open up for new technologies. And I would go so far to say we cannot solve today's problems and challenges without new technologies, and be open to ideas, concepts. And in my opinion, combining AI and robotics is the best way to answer that.
Cool.
I would assume the entire debate that here, in particular here in our country, we are having about skills shortage, that does play a huge role, and the accessibility to technology as such does play a big role. I mean, here in the daily work that we do, we observe that technology becomes more complicated, more diverse, and you can increasingly become a specialist in more narrow fields these days. That is probably also something that is an aspect in that entire debate for whether robots can replace humans, is it?
Yeah, of course. You're talking about the accessibility of new technology. This is also something where AI plays a significant role to make it easier to use, to make it easier to program, to make it more natural to interact with. Yeah, definitely.
You just mentioned programming a robot, right? And with the help of AI. So is that exactly one of the new use cases that now comes into the field, basically with all these developments in Gen AI? Or what exactly are the new use cases that you see when we add AI to this game now?
Yeah, well, actually, when we're talking about AI, there are different levels of artificial intelligence that are often lumped together a bit. So the basic level, the basic the simple side we are talking about is the area of algorithms, where we are right now, and where for the field of robotics there are the most use cases. In the next step, there is learning systems, for example, programming, co-pilots, teaching large language models, and the top level would be creativity. And this is not interesting for robotics so far. So these are the three levels. And when we're talking about algorithms, RAG models become more and more interesting, and they bear the chance to automate tasks without programming every single one of them. And one example would be to have natural language to produce the programming code, for example. And at KUKA,
question, you said creativity is not interesting for robotics applications. Why is that? Why can't robots not be creative?
Well, maybe in another field of robotics, but at the moment in what we are talking about, industrial fields, you want to do the robot exactly what you tell us.
Allow me a little joke that you don't want to have that KUKA robot that's manufacturing your car actually try out a new way to do it. You just want to have
I can totally imagine a KUKA robot painting something or playing a violin.
So I think I got this bit, yeah. So
like you don't want to have a creative dentist or whatever. So it's some kinds of things you don't want to have.
Yeah. But okay, sorry. What's your answer?
Yeah, no.
Okay,
that totally answers
got your
my
answer.
Question. It's industrial robots and applications.
I would love to come back a bit more to the field of programming robots, right? And I think you talked about it a bit. How after all actually are robots currently being programmed? How do you program a KUKA robot, for example?
Yeah. So at the moment, or in general, a robot is at first nothing but metal parts. And to make it move, you need to set specific points for it to go to. And here in our environment, we have the KUKA robot language and our own programming language to have the code written. And yeah, you need to combine these things in order to have a program and to have the specific programming parts in order to move the robot.
And is this something where Gen AI also comes in now? Because I mean, from GitHub Copilot, for example, we know that it's pretty much able to assist us in any programming language. We can just tell it, hey, sort this array and do something with it, basically, and it just writes the whole program. Does this exist for KUKA too?
Not yet, but there is a team at KUKA who is working on AI to support with creating the programming code. And also, when you're talking about GitHub, therefore we use generative AI also, yeah.
Yeah. Okay, amazing. Yeah, perfect.
In that context, let's drill into that part a little bit. I never got the pleasure to program a robot. Maybe can we take that step back a little bit for me as a total noob? Like how does one program, like do I just put in instructions that move forward and turn right, and there must be something more application specific?
Something that I've also seen actually people doing is like taking the robot arm, for example, and just moving it the way you would want to move it. But that, like now, especially in the field of AI, that kind of brings up this idea that maybe the human movement is not actually the best movement, for example, right? So maybe this could be optimized in a specific way. But sorry, I'll let you answer actually. So what about training these robots with moving these robotic arms basically and just helping them to learn? Does this still exist?
Yeah, well, everything that you both said, there was something true about it. Maybe I start with the human movements, because when you try to program a robot, that you can orient, or you can orientate on how does a human move, and there's a lot of similarities on how does a robot move. So you can transfer a lot of points there, and what you were talking about also was the collaborative robots that you can touch and you can work with, and you can use your hands to move the robot. So this is two different things. One is the industrial robot that you cannot touch while it's moving, and then you have the collaborative robot that you can move around and really work with it. And so it exists both, and you can it's different ways to program it, and that's also.
Are you basically saying that a collaborative robot that a human typically works together with would normally be programmed in a kind of I show you way, basically, right? So I would take the robot's hand and do something, and then it would just kind of reiterate over those instructions to get the task done. And while the industrial robots are probably just more programmed with scripts,
with the code. Right.
I'm also thinking about a fleet of robots. If you look at the factory plant, you have a bunch of robots. Do those guys talk to each other and you define the steps that they perform, or is that an individual effort where you have to program them individually so they in the end work together, or is there a more overarching approach to make that happen? And again, LLMs or AI to bring that in place and optimize that.
Yeah, well, what you're talking about is the robot fleets from the production plant that you see from the television with these, in our case, orange robot plants that are all over the place and producing like in automotive industry and stuff. And they sometimes work together, like they give each other some kind of material, and you have these kind of robot groups all over the place. And you can also apply large language models there, I think. It depends on, it's all about the code that you program and that you have there. And in order to have them working together, you need to adapt the code onto what they need to do. And it's called robot team, so they work together as a team. And this is a special application that we have there. And it's imaginable that you have artificial intelligence also there to support producing this code. But I need to say, it's at the moment we do not let AI produce a code and get it to the controller of the robot. But we always test it before sending it to the controller and have like a collision detection and see if everything works in the program. And therefore we have the tools and we have the software to really try it out and be sure that it's good.
I just wanted to mention this topic of security and safety, basically, right? So and especially, I mean, for single robot, it's crazy to imagine what an hallucination basically in GenAI could do, basically, right? But for a fleet of robots, that's even crazier, of course. And so it's great. So you basically use this for development, of course, but then you have your test suites and test setups that, of course, make sure that no harm is done in the real world, basically.
Well, just to take that as a leeway, and I would assume there's a lot of procedures around that, how you do that, there's best practices, all of that is documented. That would lead us back to your core competency, I guess. Let's talk about knowledge management once again. All the data that is necessary, all the procedures are necessary. Like, how do you work and process that, and to which other procedures do you provide input with the work you do?
That's an interesting question, Andreas. And the thing is that large language models, they live from rich and well-structured data. So once you have this data, it's the way to have AI implemented in your project is not that far. So you always profit from well-structured metadata and very well synapse information. And the large language models we're talking about right now, they access this data better than unstructured data, of course, and it's easier to train the AI also. And I must say that here in this industrial environment, we have a really big advantage, because we have been into robotics for 50 years now. So we know the customers, we know the industries, we know the challenges, and we can profit from it in order to have models trained. And yeah, that's a huge advantage.
Very cool. So let's maybe now talk a bit about other use cases outside of this industrial field. So you've seen the first series, right? That was about healthcare. So that was I think interesting. Or the first part of the series, it was interesting to see how robots might help in a home environment, for example, of elderly people. What other areas do you think will be influenced a lot by robotics in the upcoming years, actually?
We have a lot of challenges that we are facing at the moment, and in my opinion, it's really useful to have a technology that we can rely on, and it helps us in every way to make life easier, to make productions in every way simpler and also cheaper, because you don't need so much energy. It's not so energy consuming to produce, because technology is getting more and more efficient and more accessible also. And when I think about the use cases, I imagine some kind of sustainability plus, so to say. We can, with the help of sensors, we can do a lot at the moment in the field of battery recycling, electric mobility, for instance, and also agricultural harvesting. If you think about a robot who can differ between a red apple and a green one, which one is to be harvested. And there are a lot of fields where we can use this technology at the moment, and there are more to come.
And those are also those fields where there's typically also real skills shortage, right? Or at least a shortage in, I would say, human power, I would say, right? It's often hard to find people that, for example, get the crops off the fields, for example, here in Germany. Yeah, interesting. You mentioned sustainability. So do you think that could also lead to a new localization of production, for example? Because that's something that came to my mind, is that with robotics and with maybe making some production processes cheaper, it could actually make sense to produce more locally, for example, right? Especially when you take this to agriculture, or maybe even to some manufacturing also, where automated tasks can be, or repetitive tasks can be automated. Sorry, not the other way around. Could this happen? Is this completely
already to take a little bit of a glimpse into a potential future?
Yeah, why not? And the chance to have local production is higher if you have this technology here, and if this is accessible. If energy costs are cheaper and transportation costs are higher, imagine CO2 taxes, for instance. We don't know what the future brings, but I can imagine this will happen. Yeah, why not? The chance is high.
And then those who are still working will focus on higher level tasks, right? So we go higher and higher. Very cool.
Yeah. Right, and we are faster in implementing this, and this makes the production more lean and more economical, senseful. Yeah.
Perfect. Do we have anything else?
Like we tend to end on a positive note, like the typical question. We're a tech podcast. We like to have look into the future. Lisbeth, maybe as a last word, as a final sentence, where do you see the entire industry, like not just robotics alone, but what can robotics contribute to the future of technology and the future of society? Where are we going to end with all of that?
Yeah, in my opinion, we have a lot of challenges that cannot be solved with today's possibilities, what we have so far. And what we would like to do at the moment, we want to create automation tools that are simple and user-friendly so that anyone can access them without difficulty. And I think the technology that we were talking about in the last minutes is not just about being more efficient. It's also a solution to social issues like the lack of workers, and finding people for physical and repetitive jobs is becoming increasingly challenging. And this is where AI can help to make robotics more accessible. And yeah, I'm sure that we're on a good way, and I'm really excited what the next years will bring there. And yeah,
I'm super excited about what you just said, actually, because it's basically the democratization of robotics, basically, right? So who knows, right? And right now, it seems to be a specialized job to program a robot, and I guess GenAI can potentially help to bring this to the next million users or so, or billion users. I don't know. Don't want to make the numbers too small.
Will but create the image, and the robot will paint it.
I mean, if you have GenAI helping you to program the robot, I could honestly imagine that way more people are able to use a robot in a meaningful way, which is exciting future, really. Yeah.
Yeah.
Very cool. Lisbeth, it was great to have you on the show. Thank you so much. Thanks everybody for watching.
Thank you for being here.
Thank you guys for having me.
Yeah, it was cool, and we'll be back in about 2 weeks. And
with another robotics.
Don't forget to subscribe. It's probably somewhere down there. Bye-bye.
Thank you. Ciao.